Remember, big is beautiful, and this is true in mathematics as well. So I really encourage you to go to the effort of taking your students outside and using a piece of rope or whatever and exploring this one. Now, it might be raining, and if it's raining, I understand that maybe you want to stay inside, and you can probably do it with a shoelace or a piece of cardboard or whatever. Of course, if you went outside and you did the whole thing in the rain, they would definitely remember the time that they discovered lines. Just saying. Anyway, have students work in groups because it's more fun to work in groups, and because if you're doing it by yourself, you have to tick off each individual thing, whereas if you're in groups, you can have one student stand still and everybody else runs out in different directions. And then you actually see the circle forming. It's kind of amazing to see that happen in real life. For those who aren't so familiar with the mathematics involved here, the second one actually makes an ellipse, which is kind of like a squash circle or an oval. For faster students, ask them how the ellipse is different from the circle. And if they're really going fast, ask what would happen if they could all fly. Or if they had a rope and hummingbirds were pulling out to the ends of the rope. And they waited, they let go, and now the next hummingbird pulls out to the end out here, and the next one out here, and the next one out there. But one of the students stayed in the center. Because hummingbirds don't just make a circle. They're going to make a sphere. Or a ball. But a real soccer ball type ball. Of course, if we had two people holding the ends and hummingbirds going out, the way we did in the second part, well, then they would make an American football or a rugby ball. Right? Anyway, all in all, this task is about seeing how just a couple of simple rules, or one simple rule in this case, can describe an infinite number of points. Right? Instead of having to list each point that's on the circle, we can just say that thing that we call a circle is all of the points that are a fixed distance from this point. Or if we were in 3 dimensions, it'd be a sphere. For the next task, we're going to throw away that center and we're going to come up with different rules, and we're going to find ways of thinking about a line as a loci of points, right? A loci of points meaning a collection of points that satisfy some particular criteria. So here the loci of the points that were all the same distance from here was a circle or a sphere if we did the 3-dimensional version. But your students probably can't fly, so 3 dimensions is going to be difficult. In any event, have fun with it. Get out there, let them run around. We're just starting with circles now because circles are simple. Lines, pretty simple too, but circles, there's just one rule. Lines, we're going to have other rules. All right, have a look. We'll see what you get.